This is fourth video of electrochemistry. In this video, I will discuss on Nernst single electrode potential equation and applications of EMF measurement to calculate delta G, delta G0, delta S, delta H and K equilibrium, Ksp value, Kw and Kh value. Let us discuss on Nernst single electrode potential equation. Now we discuss Nernst single electrode potential equation. Suppose the reaction occurring in reversible cell is represented by general equation, that is A into capital A plus B into capital B is in equilibrium with L into capital L plus M into capital L, that is equation 1. Now the change in free energy delta G as a function of initial activity of reactants and final activity of the product is given by one of equation, that is delta G is equal to delta G0 plus RT into LN into A capital A raised to L activity A capital M in raised to M divided by A into capital A raised to A and A into capital B raised to small b, that is equation 2. Here A and here small a and b are moles of reactant of A and B. L and M are moles of product capital L and M. Now Q is equal to A into L raised to L into A into M raised to M divided by A into capital A raised to A and A into capital B raised to B is equal to Q. So equation 2 becomes delta G is equal to delta G0 plus RT into ln Q. When activity of all products and reactants become unity, then Q is equal to 1. And equation 3 become delta G is equal to delta G0. Here if we take ln 1, then this value is 0. So delta G is equal to delta G0, that is equation 4. But delta G is equal to minus NFE and delta G0 is equal to minus NFE0, that is equation 6. Now put the value of delta G and delta G0 in equation number 3. So minus NFE is equal to minus NFE0 plus RT into ln U, that is equation 7. Now on both side divided by minus NF value. So it is E is equal to E0 minus RT upon NF into ln Q. So it is equation E is equal to E0 minus RT upon NF into ln Q. That is equation number 9. So equation 9 is known as Nernst equation, which is used to find out potential of single electrode. For first condition, oxidation of metal electrode. Metal is oxidized into M plus N plus releasing an electron. That means oxidation is take place. And Q is equal to activity M raised to N plus 1 divided by A into M. Here product divided by reactant. So activity of pure metal M is in standard state and consider to be unity. So A into M is equal to 1. So Q is equal to A into M raised to N plus 1. Put this value of Q in equation number 9. So E oxidation is equal to E0 oxidation minus 0.0591 divided by N into log A M raised to N plus 1. Now for second condition, reduction of metal electrode. M plus N getting N electron and reduced into metal solid form. That means reduction is take place. And Q is equal to product divided by reactant. That means A into M divided by A into M raised to N plus 1. The activity of pure metal AM is in standard state and is considered to be unity. So AM is equal to 1 and Q is equal to 1 upon A into M raised to N plus. put the value of Q in equation number 9. Then E reduction is equal to E0 reduction minus RT upon NF into ln 1 upon AM raised to n plus 1. That means E reduction is equal to E0 reduction plus 0.0591 upon n into log A into m raised to n plus 1. And from this equation, we determine the EMF value of this electrode. Now, applications of EMF measurement to calculate delta G, delta S and delta H value. Delta G, delta H and delta S can be found out with the help of Gibbs-Helmholtz equation. That means delta G is equal to delta H minus T delta S minus delta G is equal to minus delta H plus T in square bracket D delta G upon dt of P. But delta G is equal to minus NFE. NFE is equal to minus delta H plus T into D NFE upon dt of P. And NFE is equal to minus delta H plus NFT in square bracket D upon dt of P. Now delta H is equal to NFT in bracket D upon dt of P minus NFE. Then delta H is equal to NF in square bracket T D upon dt of P minus E, as it is for delta S. Delta G is equal to minus NFE. Now take differentiation of this equation. D into dG upon dt of P is equal to minus NF into D upon dt of P. And delta G is equal to delta H minus T in square bracket D in bracket dG upon dt of P. And delta G minus delta H is equal to minus NFT dE upon dt of P. But delta G is equal to delta H minus T delta S. And delta G minus delta H is equal to minus T delta S. Now put the value of delta G minus delta H. That means minus T delta S is equal to minus NFT into D upon dt of P. Then delta S is equal to NF into dE upon dt of P. Now equilibrium constant K or K equilibrium. For example, CD solid oblique CD plus 2 in aqueous form, double oblique, that means salt bridge, Ni plus 2 in aqueous form oblique Ni solid. Oxidation reaction is CD solid is oxidized into CD plus 2 thus releasing 2 electron, and reduction reaction, that is nickel plus 2 getting 2 electron is reduced in nickel solid form. And cell reaction is CD solid plus Na plus 2 in aqueous is in equilibrium with nickel solid plus CD plus 2 in aqueous form. According to the want of equation, delta G0 is equal to minus RT into ln K, but delta G0 is equal to minus NFE0 and minus NFE0 is equal to minus RT into ln K, and E0 is equal to RT upon NF into log 10 raised to power K, and E0 is equal to 0.0591 upon N into log K, and log K is equal to N into E0 upon 0.0591, and K is equal to anti-log N into E0 upon 0.0591. As it is, find out solubility product of sparingly soluble salt by using EMF method. Suppose Ma is a sparingly soluble salt, ionization of sparingly soluble salt Ma into water. So Ma is in equilibrium with M plus plus A minus. At equilibrium, K is equal to concentration M plus into A minus divided by concentration of Ma. That means product divided by reactant. Then K into concentration Ma is equal to M plus into A minus. So Kp is solubility product of sparingly soluble salt. If solubility of sparingly soluble salt is S, that means mole per liter, then Ksp is equal to concentration of cation and concentration of anion. So Ksp is equal to S square and S is equal to under root Ksp value. And S is equal to under root Ksp. From this equation, we can easily find out solubility and solubility product. For example, at 25 degrees Celsius temperature, EMF of the cell is 0.40 volt and Ag/AgCl in 0.1 molar KCl solution /AgNO3 in 0.01 molar solution /Ag. In this cell, it is assumed that ionization of KCl and AgNO3 occurs approximately 100%. With this assumption, it is easily to calculate solubility and solubility product of sparingly soluble salt. On right hand side, AgNO3 is totally ionized. So concentration of Ag plus is equal to concentration of solution of AgNO3. So A2 is equal to concentration of Ag plus in AgNO3 is equal to 0.01 molar, and A1 is equal to concentration of Ag plus in AgCl solution. So E is equal to 0.0591 upon N into log A2 upon A1, that means product divided by reactant. So 0.4 is equal to 0.0591 upon 1 into log 0.01 upon A1. So 0.04 upon 0.0591 is equal to log 0.01 minus log A1. Log A1 is equal to minus 8.77 and A1 is equal to anti-log into minus 8.77. So A1 is equal to 1.69 into 10 raised to minus 9. Then Ksp is equal to concentration of Ag plus into concentration of Cl minus is equal to 1.69 into 10 raised to minus 9 and 0.01. So Ksp is equal to 1.69 multiplied by 10 raised to minus 10. As it is, solubility of sparingly soluble salt S is equal to under root Ksp value is equal to under root 1.69 into 10 raised to minus 10. So S is equal to 1.3 into 10 raised to minus 5 in mole per liter. Now hydrolysis constant Kh value. Due to hydrolysis of salt H plus and hydrogen in OH then are formed in salt solution. Degree of hydrolysis of salt can be determined by using concentration of hydrogen ion in the salt solution. Suppose salt Ba, which is made from weak base and strong acid. Hydrolysis of the salt Ba is given below. That means Ba plus H2O is in equilibrium with BOH plus H plus A minus, or B plus H2O is in equilibrium with BOH plus H plus. In initial case, concentration of this salt is 1, then product of this concentration is 0. So BOH is equal to 0 and H plus is equal to also 0 in initial state. Now in equilibrium, concentration of product BOH and H plus is C into H and it is also C into H. Then concentration of reactant is C into 1 minus H. So hydrolysis constant at equilibrium Kh is equal to C square into H square upon C into 1 minus H. Here C and C square is cancelled out. Then Kh is equal to C into H square upon 1 minus H. Here value of H is very small than 1. So Kh is equal to C into H square. So H is equal to under root Kh upon C. It is degree of hydrolysis. Now we discuss some example based on electrochemistry. First one, calculate the pH value from given data. Cell representation is platinum oblique H2 gas at 1 atmosphere oblique H plus X molar double oblique KCl 0.1 molar and Hg2 Cl2 oblique Hg, and E is equal to 0.50 volt and E calomel is equal to 0.2 281 volt. Now potential of H electrode involve H plus getting 1 electrode, it gives 1 half H2 gas. So E is equal to E0 minus 0.0591 upon 1 into log 1 upon H plus at a 25 degree Celsius temperature. And E H plus upon H2 is equal to 0 into 0.591 into pH value. So pH is equal to minus log concentration H plus, and E0 H plus upon H2 is equal to 0 volt. Then E H plus upon H2 is equal to minus 0.0591 into pH value. And EMF of the cell, E cell is equal to E calomel minus E H2 gas. So E calomel plus 0.0591 into pH from this equation. So pH is equal to E cell minus E calomel upon 0.0591. Now put the value of E cell and E calomel. E cell is equal to 0.50 minus 0.281 divided by 0.591, that is pH is equal to 3.70. Now second example, calculate the equilibrium constant Zn solid plus Cu plus 2 in aqueous form is in equilibrium with Cus plus Zn plus 2 in aqueous. E Zn plus 2 upon Zn is equal to minus 0.75 volt, and E solid Cu oblique Cu plus 2 is equal to plus 0.33 volt. So first we calculate E0 cell is equal to E0 cathode minus E0 anode. So E0 cell is equal to 0.337 plus 0.753 volt. So E0 cell is equal to 1.10 volt. So E0 cell is equal to 0.0591 upon 2 into log K equilibrium. So 1.10 is equal to 0.0591 upon 2 into log K equilibrium. So log K equilibrium is equal to 1.10 multiplied by 2 divided by 0.0591 is equal to 37.28, and K equilibrium is equal to anti-log 37.28. Then K equilibrium is equal to 1.90 into 10 raised to 37. Now third example, calculate equilibrium constant K equilibrium of Sm plus 4 plus 2Cr plus 2 is in equilibrium with 2Cr plus 3 plus Sm plus 2. Here E0 Sm plus 4 oblique Sn is equal to 0.140 volt, and E0 Cr plus 2 oblique Cr plus 3 is equal to minus 0.380 volt, and N is equal to 2. Now E0 cell is equal to E0 cathode minus E0 anode is equal to 0.140 plus 0.380 volt. Then E0 cell is equal to 0.5. Then E0 cell is equal to 0.520 volt. So 0.520 volt is equal to 0.5901 upon 2 into log K equilibrium. So log K equilibrium is equal to 0.52 multiplied by 2 divided by 0.0591 is equal to 17.59, and K equilibrium is equal to anti-log into 17.59, and K equilibrium is equal to 3.95 to 10 raised to 17. Now fourth example, EMF of the cell is 0.952 volt at 25 degrees Celsius. PB oblique PB plus 2 activity is 1, and double oblique AG plus activity is 1 and oblique AG. First write cell reaction, and second is calculate delta G0 in joule and calorie. First thing, write cell reaction. Oxidation reaction is PB solid is oxidized into PB plus 2 aqueous form releasing 2 electron, and on reduction reaction 2 Ag plus getting 2 electron and reduced into 2 Ag solid. And the cell reaction is Pb solid plus 2 Ag plus is in equilibrium with Pb plus 2 in aqueous form plus 2 Ag solid. Now second, calculate the delta G0 in joule and calorie. For this reaction N is equal to 2. Then delta G0 is equal to minus NF E0 is equal to minus 2 multiplied by 96,500 multiplied by 0.95 volt is equal to minus 1,83,736 calorie volt per mole, and 1 calorie volt is equal to 1 joule. So delta G0 is equal to minus 1,83,736 kilojoule per mole. Thank you.